Okay, this is MET 1122 Fundamentals of Statistics. The objective of the course is to develop quantitative skills and problem solving skills in order to foster the critical thinking essential to the world of today and tomorrow. And if you go through the course content, this is actually the course outline. The introduction will be there, organization and description of data, introduction of statistical survey, data collection methods, sampling techniques, designing of questionnaires, presentation of data, summary measures, and introduction to the correlation analysis will be discussed under this course module. Okay, this is the introduction for this course. As soon as you see about this picture, you can see that two people discussing about something, and one is just stating that I do not know how to do statistics, but he does not matter about it. It is because he does not have any data. Therefore, without data, statistics is nothing. Therefore, the number one thing or the most important thing in statistics should be the data. And we can say, therefore, we can say that statistics is the science of data. It involves collecting, representing, analyzing, and interpreting numerical information. Therefore, actually, statistics is the science of data, and it consists of four parts: data collection, data representation, data analyzing, and data interpretation. Therefore, the combination of these four techniques can be called as a science, and it is named as statistics. When we look about the statistics, then we have to familiar with some wordings. It is because you have to be familiar with these terms actually. Now we will go through them one by one. The first term is population, the total set of observations that can be made. As an experiment, now you think that if you are going to if you need to take uh, you are just doing an experiment and you need to identify what is the mean weight for the university first year student. You need to identify what is the mean weight. Therefore, your population would be all the first year university students in Sri Lankan universities. But Hmm? Is it possible to collect the data from all the students? If you are considering the total area of interest for your experiment is Sri Lankan uh, university students of first year. Therefore, we can say it as your population. It is the total set of observations that can be made. But with the limitations, it may be time limitations, and then the economic limitations would be there. Therefore, without considering the whole population, what we are most of the time, we are limiting it to a sample. Therefore, if you are having a large population, then we can take out a small sample. Therefore, a sample is the set of data collected or selected. Can be collected or else selected. If you already have in the population data, then randomly you can select it. Therefore, sample is a set of data collected or selected from a statistical population by a defined procedure. Therefore, if you are having the population, if you are having the population and you are trying to obtain a sample, when you are obtaining the sample, you cannot select or collect the data as you wish. It is because there should be a proper way of collecting or selecting sample from the population data. That is what is defined as the defined procedure. Therefore, you can obtain a sample from the population. And if you move to the this is the pictorial way that I have explained it. This is the population. Means you can consider this as the whole Sri Lankan university students who are in the first year. But you have taken a sample from them. It is like just 10 students from each university. Each university first year batches, you can identify 10 students and you can measure their weights. Therefore, from a population, using a proper sampling technique or or the defined procedure, you can obtain the sample. Then when you are discussing about the statistics, there are two types of statistics. There are two types of statistics. First one is descriptive statistics and next one is the inferential statistics. Therefore, we can divide the statistics into two parts. Number one, descriptive statistics. Number two, inferential statistics. And if we see about the descriptive statistics and inferential statistics, now descriptive statistics, this make conclusions based on the samples. Based on the samples, you can make conclusions, and such statistics are called as the descriptive statistics. If you look about the inferential statistics, it describe and make inferences about the population based on the sample of data taken from a population. Therefore, if you see about these two, descriptive statistics and inferential statistics, actually statistics can be divided into two parts, descriptive, inferential. Therefore, if you see about this picture, what we have done was, from the population, you have identified the sample. Then based on this sample, if you are making any decisions, then it is coming under descriptive statistics. Based on the sample, if you are making any decisions, then it would be the descriptive statistics. But if you are going to tell anything regarding the population, now think about, based on the sample, you are generalizing it for the population, then that procedure would be taken as the inferential statistics. Now you can easily understand what is the difference between this descriptive and the inferential statistics. In simply, if you are making decisions based on sample, it would be descriptive statistics, and if you are going to state or inferencing about the population based on the sample data, it is said to be the inferential statistics. Okay, these are the another set of terms that we have to pay our attention. The next one is variable. A variable is any characteristic, number or quantity that can be measured or counted. Therefore, variable is any characteristic or any number or any quantity which can be measured or counted. If you cannot measure or counted, then you cannot assign it as a variable. Then for a variable, you are assigning the values. It means that you can assign the values by measuring it or by observing it. Therefore, if you are getting the measurements or observations or the values for a variable, then we are calling them as the data. Data is the measurements or observations for a variable. Then next term is the random variable. A variable whose possible values are outcomes of a random phenomena. Then we are saying it as the random variable. It is like this. Now think about if you are tossing a coin. If you are tossing a coin, then based on the tosses, you are assigning the values for your variable. Therefore, the outcomes are coming under a random phenomena. Therefore, if your outcomes are coming under a random phenomena, it is because until the coin is landing, we do not know whether we are getting head or tail. Therefore, if you are tossing a coin, until you are getting the landing of the coin, you do not know whether the surface would be head or the surface would be a tail. Therefore, since the outcome is coming under a random phenomena, then we are saying such um, variables as the such, if you are assigning such values for variables, then such variables are said to be the random variables. Okay, now this is actually the introduction. Therefore, if you just quickly summarize them, what we have discussed, then here you have learned what is statistics. It is the science of data, consists with four parts: collection, representation, analyzing, and interpretation of the information. Then you have gone through two terms, population and sample. Population is the total set of observations that can be made, and then sample is data collected. Actually, it is a subset of a population. It is because and this sample has obtained from population using a defined procedure. For the pictorial is giving the same idea from population. Using appropriate sampling technique, you can obtain the sample. Then there are two types of statistics: descriptive statistics and inferential statistics. Descriptive statistics make conclusions based on samples and describe inferential. For these inferential statistics, inferencing or describing about the population based on the sample data. Then variable, data, and random variable. Variable, any characteristic, number or quantity that can be measured or counted. Then the measurement or the observation for a variable is named as data. And if a variable whose possible values coming under a random phenomena, whose outcomes coming under random phenomena, then we are saying such variable as the random variables. Okay. Now we will go for the organization and description of data. Organization and description of data. Normally, statistical data are usually obtained by counting or measuring the items. Therefore, when you are counting or measuring the items, most of the data can be again divided into two categories. Those two categories are the qualitative data and the quantitative data. Therefore, you can say data can be divided into two categories. First one is qualitative data and second one is the quantitative data. Now, if you go through these two types of data, qualitative, quantitative, then if you go through this qualitative data based on the quality, based on the quality, you are getting the measurements, then you can say such a thing as the qualitative data. But if you are having measurements based on a quantity, then you have to categorize it under the quantitative data. If you go through this part, this qualitative data, measurements that each falls into one of the several categories. Qualitative data is also called as categorical data. Therefore, if you are having several categories, then rather than having the values, then such type of data would be said to be qualitative data. It is based on quality. It is likewise short and tall, good, better, best. Then hair color. If it is hair color, then it can be white, black, brown, red, blue. Likewise, there may be so many hair colors would be there. Therefore, such a thing can be named as categorized under qualitative data. And if you are having your names, Nimal, Kamal, Saman, likewise, you may have this again the qualitative data. Another name for the qualitative data is the categorical data. Another name for qualitative data is categorical data. The quantitative data, observations that are measured in numeric or quantitative manner. In the name itself, it has the meaning of based on quantity. Therefore, if you are taking the observations based on quantity, or if you are having them in a numeric manner, then you may say such data as the quantitative data. Okay. These are the examples for qualitative data and quantitative data. For the qualitative data, you can have hair color, gender, field of study, college attendant, political affiliation, status of disease, infection. If you consider about this variable hair color, then you can have white, black, brown, red, likewise so many categories. If it is your variable is gender, then you can have male and female, again two categories. Field of study, if you are considering A-level students, if you are going to school and you are asking what is the field of study from a student, then they may give the ask whether it is technology, then that is mathematics or biological science, arts and commerce. Likewise, they may say their field of study. Therefore, rather than having the numeric values, you may have names, then or some based on some quality, they are having their observations. And then college attendant, if I ask about your school, then you may not say it is 1 2 3 4 likewise. You may say it is your college is this. You may say your college name. Same for the political affiliation and status of disease, infection, whether it is infected or not infected. If it is the quantitative data, it is based on actually a quantity. Then what we can have as example: height, age, crop yield, GPA, salary, temperature, and area. Those are just some examples which we can consider under the quantitative data. If you consider about the first variable height, if I ask the what is your height, you may give the answer as my height is 163 centimeters, my height is 130 centimeters, it may be 150 centimeters. Likewise, you may have the numeric value. If I am asked your age, you may say that I am 21 years old, I am 19 years old, I am 23 years old. Likewise, you may give the answer. And if I ask your GPA, you may say my GPA is 4.0, 3.7, 3.69. Likewise, you may say your GPA. Salary, temperature, and area can be considered as another example for the quantitative data. Then we will come to the one of the most important part. It is the scale of measurements. Scales of measurements refer to ways in which variables or numbers are defined and categorized. Actually, when we go through this previous slide, actually we have divided the data into two basic types. It is the qualitative data and quantitative data. But if we are furthermore dividing this type of data, then this concept of scale of measurements comes to the stage. It is because based on the scale of measurement, we are trying to identify which statistical method I am using to analyze for these data. It is because all the statistical methods that you are learning would not be appropriate for each and every type of data. As a simple example, if I say about this, if I am asking um, your age, I am asking you, I am asking you a weight. If I am asking you a weight and you think that you may have given the answers as my weight is 55 kilograms, 50 kilograms, and 45 kilograms. If I need to get the average value of these three, what can I do? I can add 50, 55, and 45 together, and then I can divide it by 3 and I will get the answer as 50. Therefore, if you are having the numeric data, you can calculate the average. But if I am taking your names and if I am trying to take the average, can I do it? We cannot do it. It is because if your names are Saman, Nimal, and Kamal, and can you add those three names and divide it by 3? Definitely you cannot do it. That is why for all types of data, all the statistical methods cannot be used. Therefore, the statistical methods can be used for specific types of data. Therefore, those specific types of data can be easily identified using this scale of measurements. If you discuss about this scale of measurements, each scale of measurement has the certain properties which then determines the appropriateness for use of certain statistical analysis. This is what I have mentioned you previously also. All the statistical methods cannot be applied for all types of data. Only for several types of data, several methods can be used. In the simplest example I have taken, you cannot calculate the average for names, but you can calculate the average for your weights. If we discuss about scale of measurements, there are four types of scale of measurements. Number one, nominal scale. The second one, ordinal scale. Then third one, interval scale, and fourth one is ratio scale. Therefore, there are four scales of measurements: nominal, ordinal, interval, and ratio. If you go through these four scales of measurements one by one, first of all, we will discuss about the nominal scale. In the word itself, you can easily understand that nominal, it is stated somewhat like the names. Therefore, if you are considering the nominal scale, the categories do not have any logical order. Categories do not have any logical order. It is simply, if you are having like this, if you are having gender, you may have the values as male and female. Can you make it in the ascending order or descending order? There is no such logical order there. Therefore, you can just have in two categories only. You may have males and females. And then arithmetic operations would be inappropriate for a variable on nominal scale. That is the example which I have taken previously. If you are having your names, you cannot add, subtract, multiply, or divide your names. It is because those you cannot apply arithmetic operations on your names. Therefore, if you are having any data on the nominal scale, the arithmetic operations would be inappropriate. But sometimes we are using, here I told you that we are using sometimes the categories as the names, but sometimes we are using numbers instead of the names. If even though we are using the numbers, you cannot go for the arithmetic operations. As an example, now think about if you are having your variable as gender, then what are the groups you are having? There are two types, female and male. If you name female as 1 and males as 2, females as 1 and males as 2, here this one does not having a numeric value, it just has the identification only. This one says that the data point is from a female. Then if that data point has the value 2, then we can say that that data point is from a male. Therefore, even though we are naming the categories using the numbers, you cannot go for the arithmetic operations if your original data are in the nominal scale. These values are just for the identification only. The second scale of measurement is the ordinal scale. In the nominal scale, there was no any logical order. But once you come to the ordinal scale, what you can see here is this ordinal scale is also consist of categories, but there is an order there. Now think about if you are rating, uh, a book. If you are rating a book, then what you can say? The book is good, or else can say it as the better, or it is a best book, or you can say it is bad also. But there is a order. Clear? Now think about your gradings. Your gradings. How about your gradings? It starts from A plus, then somewhat lower A, then somewhat lower A minus, then B plus, then B, then B1. Here also you are using categories, but there is a logical order here. Therefore, this is somewhat advanced from the nominal scale. In the nominal scale, you just have the categories only, but no any logical order. But in the word itself, ordinal, then still we are having categories, but there is a order which we can imply, and still we cannot use the arithmetic operations if our we cannot still use the arithmetic operations if our data is in the ordinal scale. In here also sometimes we are using the numeric values to uh, just for the representation for the categories, but still you cannot have the arithmetic operations even you have used the numbers. As an example, now think about if you are having 1 2 3 for a mind, 4 for B plus, 5 for B, and 6 for D. Rather than using A plus, A minus, B plus, B, and B minus, you can use the numbers to denote them. Even though you are using the number, how can you add this? 1 plus 2 divided by 2. Can you take this as A plus A divided by 2? This is inappropriate. This is inappropriate. You can do the calculations in this way. These numbers that we have used is just for the representation of data only. And if you move for the next one is the interval scale. Next one is the interval scales. Here you can see the data is in an ordered manner and equal intervals on the underlying characteristics. As an example, now think about if you take this, if you take the temperature of the day. If you are taking the temperature of the day, then you may have 20, 30, 40, likewise you may have the values. Therefore, if you consider any two intervals, here value is 20, 30 and 40. Therefore, the distance between these two would be same as the distance would be these two. As an example, if you are considering numbers 1, 2, 3 and 4, likewise, if you are considering the distance between any two numbers, the distance between any two consecutive numbers, then this distance would be same as this distance. The distance cannot be vary since it is at the interval scale. But there is a special thing in the interval scale. The special thing in the interval scale is interval scale do not have a true zero. Scales do not have a true zero. As an example, if you think about the temperature in Celsius, Celsius degrees, then the Celsius degrees does not have a true zero. Only the Kelvin scale has a true zero, not the Celsius. You may have learned it previously. For if you are having your data at the Celsius degree scale, then you may not have a true zero. Therefore, the temperature in Celsius can be considered as an example for the interval scale. The most important thing in the interval scale is interval scale do not have a true zero. Then numerical scales in which intervals have the same interpretation throughout. That is what I have said previously also. Then in between these two, the same value range will be there. In between these two, again same value will be there. In between these two, again same value range will be there. Therefore, throughout this same interval, which intervals, throughout the intervals you may have the same interpretation. Here you may have the equal intervals based on the underlying characteristics. And if you move for the next one is the this is one example. Consider the Fahrenheit scale of temperature. It is another example for the interval scale, Celsius or Fahrenheit. Then you can have difference between 30 and 40. And again we will consider difference between 90 and 100. Then 10-degree interval in between these two, the difference would be 10 degrees. In here also you may have 10 degrees. Therefore, in between these two, so in between 30 and 40, you may have 10 degrees. In between 90 and 100, again you may have 10 degrees. Therefore, that 10 degrees interval has the same physical meaning. But no one can say that between 30 and 40, that 10 degrees is this much and 90 and 100, the 10 degrees is this much. You cannot comment like that. If it is 10 degrees, you may have the same physical meaning. And the last scale of measurement is the ratio scale. The only difference between the interval scale and the ratio scale is the ratio scale has a true 0 point. Interval scale does not have a true 0 point. Ratio scale has a true 0 point. And same as the previous, given interval has the same interpretation for the entire scale. And if you are using a ratio scale, one advantage that we are getting is we are sensible to talk about one value being twice as large as another. Now think about if you are having the area. Now think about if you are having a land with uh, 20 perches. If you are having a land with 20 perches and another one person has a land with 40 perches, then you can say that that person has a land as 2 times as mine. Therefore, it is sensible to talk about one value being twice or large as other. Then you may have think about 10 purchase you may have then, or you may have 10 units, and you will think about one student has 10 pens and another student has 40 pens. Then they can say this student can come in, the student B has 4 times as me once we are considering the pens. Therefore, it is sensible to talk about whether how many times it is being larger or how many times it is being smaller. It is because if we are commenting, then he is saying that if you are counting pen, you may have 1/4, you may have a quarter time, it is 1/4 time of the pens which I am having with me. Therefore, likewise, it is sensible to talk about one value being twice as large as another. And if you go for the next one, it is just the properties of the scale of measurement. This is what we have discussed so far. Then we have discussed about nominal measures, nominal scale of measurement, ordinal scale of measurement, interval scale of measurement, and the ratio scale of measurement. All these four scale of measurements having the identity. All four has the identity. In here nominal we may have categories. In here ordinal again you may have categories. Then in the interval again you may have the categories. Then in the ratio also again you may have the category, you may have the value. Therefore you may have the identity for all four scale of measurement. But once you consider about the magnitude, for the nominal scale you do not have an magnitude. It is because if you think about your names Nima, Kaman and Sama, which has the largest value. No one can say whether it is Nimal, Saman or Kamal. Who has the smallest value for their name? You cannot comment like that. Therefore, nominal scale of measurement do not have a magnitude. But for the ordinal, you are having a magnitude. Once you compare A plus with A, then you can say that A plus is higher than A, or A minus is lower than A. Then interval also you may have the magnitude. Here ratio also you may have the magnitudes because you are having the quantitative values. And for the nominal and ordinal you do not have the equal intervals. Therefore for the ordinal you may have, if you are assigning values for A plus and A, then the gap between those two may be just the 5 points. But if you are just having A minus with A, then that mark would be around 10. Then if it is A minus and B plus, then again mark would be 8 or 9. Likewise, there would be not equal intervals between any two consecutive values for nominal data or the ordinal data. But if you are discussing it with the interval or the ratio scales of measurements, definitely you must have the equal intervals. And if you see about this true 0 point, nominal, ordinal, interval, none of them are having a true 0 point. It is because we are not discussing any numeric value for nominal or ordinal data, but we are discussing it for interval data. The special quality of interval data, we are saying it as the there is no true 0 point. If we are having a true 0 point, it is sensible to talk this is this much times larger than the next one, or this item is this much time smaller than the next item. Likewise, if you are having only a true 0 point, we can, it is sensible to talk in that way. Therefore if you are having the data in the ratio scale, then you may have a true 0 point. Therefore these are the properties of the scales of measurements. Okay, in here you are asked to identify the scale of measurements. Therefore now think about, if you are having the smoking status, then you may have the answers as yes or no. Definitely you can have the first one under the nominal scale. Smoking status, you can say it as the nominal scale. Then birth weight of a baby, then you can consider it under the ratio scale. If you are comparing any two babies, then you can say this baby is 2 times weighter than the next baby. Likewise you can say, therefore it's sensible to talk this much of times. Therefore, and also the next thing is weight is also having a true 0 point. It is because if there exists a true 0 point, then now think about, if weight is 0, there is nothing. Therefore, but if 0 Celsius implies that there is no any temperature there, it is not like that. It is because even though it is 0 Celsius, there would be a temperature. But if it is 0 kilograms, then there will not be any weight. Therefore, we are having a true 0 point at the weight. Therefore, the second one can be considered under the ratio scale. Third one, temperature in Celsius scale. In the Celsius scale, even though we are having a 0 point, it is not a true 0 point. It is just a relative 0 point. It is because if you are considering zero Celsius, then you may have some temperature there. And if you, therefore we can consider the third one under the interval scale. Fourth one is temperature in Kelvin scale. If you are considering the 0 Kelvins, definitely there is no any temperature. If the temperature is in the Kelvin scale, 0 Kelvin says that there is no temperature. Therefore, here you are having a true 0 point under the Kelvin scale. Therefore, you can say this as the, this you can categorize this under the ratio scale. Again, age is again ratio scale. He is 2 times older than me. It is because 0 age says that there is nothing. 0 age says that there is nothing. Then weight gain, hmm? Weight gain, grade of meat. Grade of meat, what we can say? Grade of meat, you can say it is a good, the meat is good, or you can say the meat is bad. Therefore, but you are having just the categories, but it is in a logical order. Therefore, grade of meat, you can consider it under the ordinal scale. Therefore, this is how you can identify the scale of measurement according to the situation or according to the variable that you are interested. And if you move for the next part, these are the types of variables. If we come to the point of the variables, again variables can be divided into two categories. First one is the discrete variable and second one is the continuous variables. If a variable which can take only the finite numbers, if a variable can take only the finite numbers, then such a variable is said to be a discrete variable. Therefore, all the qualitative variables are said to be the discrete. It is because now think about if you are having your name, you are having Nimal, Hamal, Saman, then Ajit, likewise, you may have the names. But in between those two names, can there be any other names? There cannot be any other names. Then if you are having the hair colors, then what can you have? Hair colors. What are the colors you can say? It is white, it is black, it is brown, red. Likewise, you may have the colors, but those are just the discrete values. In between this white and black, you cannot say blue is in between these two. There is no, we cannot comment like that way. Therefore, all the qualitative variables are said to be the discrete variables. But once you come to the continuous variables, variables that has an infinite number of possible values. Now, if you see about this, now think about if you are considering a weight of a student. If you consider weight, if this weight is, if you are drawing the scale, here it is 20 and here it is 30. In between 20 and 30, you may have another value, 25. In between 20 and 25, again you may have 21. In between 20 and 21, you may have 20.5. Therefore, in between these, any of the two values, there would be infinitely many. It is because in between these 20 and 20.5, you can divide this very small part into millions of parts. It is because we are having infinitely many number of times. Actually, it's not millions. Actually, it is infinitely many number of times. Therefore, variables that has an infinite number of possible values are said to be as the continuous variables. This is the difference between discrete variables and continuous. For the discrete variables, they will have finite numbers of values. If it is continuous, it has the infinite number of values in between any considered range. Then these are some practice questions. If you go through this, here you can complete this below table. If you go through, in the first column, you may have the variables. In the second column, you have to state whether it is qualitative or quantitative. Then you have to say about the scale of measurements, whether it is nominal, ordinal, interval or ratio. Then next one is the whether it is discrete variable or continuous variable. Okay, first of all, we will fill the second column whether it is qualitative or quantitative. Okay, if you see about the first variable, names of these students, definitely it should be a qualitative variable. It is because names does not have any numeric values. Therefore, you can have it as qualitative. Grades obtained for the course. Grades. Then you may have A plus, A minus, B plus, B minus, D, C, F. Likewise, you may have the letters only. Therefore, again, you may have the qualitative data. Here it is not the marks. Here it is just said as the grades. Grades means you may have the letter grades. Therefore, again, you will have the qualitative data. Then next one is temperature of the days in a week. Temperature of the days in a week. Since it is temperature, then definitely you may have the numeric values. Therefore, it would be a quantitative variable. Then height of the students. Height of the students, again, it is quantitative since you are having the numeric values. Then number of students in each degree program. Then if you are considering number of students, then you are counting it. Therefore, again, this would be a quantitative variable. Therefore, once you are summarizing the answers for these variables, then you will get it in this way. For the first one, qualitative. Second one, qualitative, since grades, letter grades, temperature, numerically quantitative, height, numerically quantitative, number of students, numeric value, again it is quantitative. Now we will see about what are the scales, appropriate scales of measurements for this data. Here still you are having the names. Names are, you do not have any logical order. You can only have in the identification only. Therefore, you can say this under the nominal scale. It is because if you remember this chart, then you can say nominal has only the identity only, no magnitude, no interval, equal intervals, no true 0 point. Therefore, based on this table, you can provide the answers for this. Therefore, here name does not just have the identity only. Therefore, you can have it as the nominal scale of measurement. Grades. Here you are having the identity as well as grades are having an order. Therefore, since it is in the ordered way, therefore you can have it as the ordinal scale of measurement. Then the temperature of days in a week. Normally, we are measuring the temperature using the Celsius scale or the Fahrenheit. It is better to make this as Celsius or Fahrenheit. If you are considering it as the Celsius scale or the Fahrenheit scale, definitely you may have not any true 0 point there. Since we do not have a true 0 point there, then we have to categorize it under the interval scale of measurement. Height of the students. For the height, you may have a value in between any two consecutive centimeters. There are infinitely many values. Therefore, and also you can say this student is 2 times taller than the next student. Therefore, you can it is sensible to talk since we are having a relative true 0 point, not a relative zero. Since we are having a true 0 point, then we can categorize this as the ratio scale. Then number of students in each degree program. Here also 0 number says that there is no any student. Therefore, here also you are having a true 0 point. Then you can say here also you are having it under the ratio scale. Therefore, once we are summarizing the values that we have obtained, then we can say it as nominal, ordinal, interval. These two are ratio scales. Now, we have to identify whether these are discrete or continuous. If you are having names, definitely you do not have any continuous values in between any two names. Therefore, definitely this should be a discrete variable. If it is grades in between A plus and A, you do not have any other value for the letter grades. Again, the second one should be also a discrete. Then temperature. Temperature, definitely you are having infinitely many more values in between any two intervals. Therefore, you may have to consider it as continuous. Then height of a student. Height of a student, again, if you are considering any two consecutive centimeters, then there would be infinitely many number of values. Then therefore it is also categorized under continuous. Then number of students. If you are considering student number as 2 and 3, then in between 2 and 3 there cannot be any student, there cannot be any half of a student. Just like this. Now think about if your degree program has 20 and another one has 21. The next value is 21. Then in between 20 and 21, do we have any other students? Hmm? Hmm? We do not have any other value in between this 20 and 21 in the context of this variable number of students in each degree program. Therefore, definitely this should be also a discrete. According to the variable, you have to identify it. Therefore, if you summarize the values that we have obtained, then we can take the values as this first one, second one, and final one is discrete variables, and third and fourth ones are the continuous variables. Okay, this is one thing you can go through it. State whether the following statements are true or false. Here they are saying Celsius and Fahrenheit temperature scales are examples for interval levels of measurements. Here they are asking about Celsius scale and the Fahrenheit scale. If you are measuring the temperature using Celsius or Fahrenheit, definitely we know that both of these scales do not have a true zero. It is because 0 Celsius means there is somewhat a temperature. 0 Fahrenheit means again there is somewhat a temperature. Therefore, you do not have a true 0 point. Therefore, this is coming under the interval scale.